Hi, I'm Mrs. Rutchling. Welcome to this installment of Chapter 6, where we're going to look at the moles of atoms or ions in a compound. If we look at our compound, we can look at it different ways. We have 1 mole of the entire compound. Within that 1 mole, there is 1 mole of aluminum atoms and 3 moles of the nitrate ions, or we could even get more specific and say there are 3 moles of nitrogen atoms and 9 moles of oxygen atoms. So we can look at it as a conversion. If we have a 3-leaf clover, how many leaves? Well, there are 3, and we can use that as a conversion factor. So if we have 14 clovers, we can figure out that there are 42 leaves. So we're taking the part and its relationship to the whole. We have our familiar grams to moles to particles, and now we've added using the formula as a conversion factor to get to the number of atoms or ions. This takes advantage of the part to whole relationship. For example, if we wanted to know how many moles of hydrogen were in moles of water, we could use this relationship because for every mole of water, there are 2 moles of hydrogen. Let's give it a try. We have 1.7 moles of calcium carbonate, and we want to know how many moles of oxygen. If we look at our whole formula, we see that there are 3 moles of oxygen, so we can use that relationship to go from the whole to the part. And we have 1.7 moles of calcium carbonate. We multiply it by that relationship, and we end up with just moles of oxygen. Let's try one. We want to know how much sodium is in 15 grams of sodium chloride. If you recall at the very beginning of the chapter, we talked about health and how much sodium you should have, and how can we find that out when we have the sodium combined with the chloride? Well, we're going to start with our 15 grams of sodium chloride, and we need to change it to moles. We have no conversion factor that doesn't start with moles, so we use the molar mass from the periodic table, and we can cancel out the grams. Now we have 1 mole of sodium chloride, but we want to know something about sodium. And so we use that relationship where there's 1 mole of sodium for every mole of sodium chloride. And once we cancel, that gets us to moles of sodium. But it does ask for mass, so we go from moles to grams using the molar mass from the periodic table. We end up with 5.9 grams of sodium, again using the sig figs from the beginning. Pause the video and try this problem. The first thing you need to do is write your formula for chromium 3 oxide. The first thing you need to do is write the formula. Chromium's charge is given by the 3, and oxide has a 2 minus, so when we cross, if we have moles of chromium, and I think I probably did chromium ions, we look at the relationship here, and there are 2 moles of the chromium ions. Notice it has the charge because it asks for the ions. So there are 2 moles of chromium ions in 1 mole of chromium 3 oxide. That gives us 2 moles of the chromium ion. We also do the oxide ion. There are 3 moles of the oxide ion, and since we have started with 1 mole, we have 3 moles of oxygen. Pause the video and give this one a try. Starting off with moles of water. Since we have moles of water and we want hydrogen, starting off with our given, we need to go to atoms of hydrogen. So let's use the relationship of 2 moles of hydrogen for every 1 mole of water. That will give us moles of hydrogen. So we have the correct species, but we need to get to atoms. To get to atoms, we need to use our Avogadro's number. Again, we can cancel out moles, and it tells us how many atoms of hydrogen we have.